One of the things that's easy to lose sight of when you're doing chemistry in class is that this is more than just work that you do on a sheet of paper. Chemistry is something practical. It's actually the creation of compounds and using those for purposes that we have. And so one of the big problems we have in chemistry is we have to be able to measure amounts. We actually have to know how much stuff we're working with. And as we saw when we dealt with chemical reactions, is that those chemical reactions are based on the amount of atoms or molecules. So let's take a look under the camera, and you're going to see that if we write out some kind of chemical equation, so I'm just going to say, like, let's say CaOH2 reacts with HBr, and that produces water, and CaBr2. And now we want to balance this, so we would say, okay, I have 2 Brs here, I need 2 Brs here, that gives me 2 H's, and another 2 H's is 4 H's, so I need 4 H's, gives me 2 O's, here I've got 2 O's, and now we're balanced. Okay, here's the thing though, those coefficients, remember coefficients are the numbers that we placed in front of each of the molecules. They represent the number of atoms or molecules that react. So what I'm really saying is for every 1 calcium hydroxide, there needs to be 2 hydrobromic acids that react. That is actually going to make 2 molecules of water and 1 molecule of calcium bromide. So why is this a problem? Well, the problem is if you wanted to measure things in a lab, you don't measure the amounts of atoms. You measure their mass. So you put them on a scale, the scale measures a mass. And here's the issue, is that not all atoms have the same mass. As we saw, mass is based on the number of protons and the number of neutrons. And so we need a way to relate the mass to the actual amount of atoms in a substance. So how do we do that? Well, we do this using one particular value. And this value is what we call the mole. The mole is just a way that we can relate how much of a substance we have. And I think the best way to consider a mole is to think about a dozen. Let's say you had a dozen, that means you have 12. So if you have a dozen donuts, you have 12 donuts. If you have a dozen marbles, you have 12 marbles. If you have a dozen eggs, you have 12 eggs. If you have a dozen elephants, you have 12 elephants. And if you had a dozen hydrogen atoms, you would have 12 hydrogen atoms. But since atoms are so small, we use a much bigger version of a dozen. We use what's called the mole. And the mole is based off what is called Avogadro's number. And so Avogadro's number is 6.02 times 10 to the power of 23. So if I have a mole of donuts, I have 6.02 times 10 to the 23 donuts. If I have a mole of marbles, I have 6.02 times 10 to the 23 marbles. If I have a mole of eggs, I have 6.02 times 10 to the 23 eggs. If I have a mole of elephants, I have 6.02 times 10 to the 23 elephants. And if I had a mole of hydrogen atoms, I would have 6.02 times 10 to the power of 23 hydrogen atoms. This is how we relate substances to each other, is using the mole. Because we can take a mole of hydrogen and actually find out how much it weighs. We can take a mole of carbon and find out how much it weighs. And we can take a mole of calcium hydroxide and find out how much it weighs. So how do we do that? Well, we need the periodic table. So I've been talking about hydrogen a fair deal in this video, so what I wanted to do was show you how we can find the molar mass, or the amount of mass that something like hydrogen would have. So let's take a look at that periodic table, and on that periodic table we're going to zoom in to hydrogen. And so if we zoom in on hydrogen, one of the things you're going to see is this number at the bottom. Previously we called this number the atomic mass, but what's probably a more accurate description right now for the way that we are going to use this is to call it the molar mass. And so what we mean by that is the mass of 1 mole of hydrogen. And so that's a term that we are going to use probably on a daily basis here in chemistry, is the molar mass. And what we mean by the molar mass is the mass in grams of 1 mole of a substance. And so when we talk about hydrogen, if we had 1 mole of hydrogen, it would have a mass of 1.01 grams. And the way that we would typically write this is we would say that the molar mass of hydrogen is 1.01 grams per mole, because that's how many grams are in 1 mole of hydrogen. So let's look at a different substance on the periodic table. Let's say we were dealing with something like carbon. So what you would want to do is turn to your periodic table, find carbon on that periodic table, and look at the actual, what we used to call the atomic mass, which we now call the molar mass, and we would find that it has a molar mass of 12.01 grams per mole. What about something like sodium? Well, it has a molar mass of 22.99 grams per mole. What's important to understand is we may have different masses, but all of these have the same number of atoms. So a mole of hydrogen may weigh 12 times less than a mole of carbon, but they both have equal amounts of atoms. A mole of carbon may be about half that of a mole of sodium, but they have the same number of atoms. 1 mole is 1 mole is 1 mole. It is always 6.02 times 10 to the power of 23. So then how do we deal with this when it becomes a compound? That's kind of the next thing we need to look at, because I mentioned something about calcium hydroxide. So calcium hydroxide is CaOH2. So what if I needed to find the molar mass of something like calcium hydroxide? Well, here's what I need to do, is I need to find the mass of everything in it and add them all up. That would be the molar mass of calcium hydroxide. You see, calcium hydroxide has 1 calcium. And then it has, keep in mind this number outside the brackets applies to everything inside. It has 2 oxygen atoms. That's an O, by the way, not a 0. And we have 2 hydrogen atoms. So if that's how many atoms are actually in this molecule, then we can apply the same rule to the mass. To find the mass of calcium hydroxide, we need to know the mass of calcium. So the mass of calcium should be 40.08 grams per mole. Oxygen is 16.00 grams per mole. But because there are two of them, we need to multiply that number by 2. So what that actually means is the mass of oxygen in this compound is 32.00 grams per mole. And hydrogen, well, hydrogen has a mass of 1.01, but there are 2 hydrogens, so we need to multiply that number by 2, and it means that we have a mass of 2.02 grams per mole. So what's the mass of calcium hydroxide? Well, we just need to add all of those numbers up. So what do we get? You should get 74.10 grams per mole, as long as I did my math correctly. And so that's how we find the molar mass of a substance, is we calculate the amount of mass from each of the substances and then add them all together. You may be wondering, do I have to write out all the work for this? No. In fact, this is something that I would hope you get to the point where you don't write the work out for it, because it's kind of a stepping stone in what we do next, which is learning how to do conversions using the mole. So thanks for watching, keep practicing, and I'll see you next time.